fill in our unit circle in the first quadrant. So 0 degrees or 360 degrees, it's 1, 0. 30 degrees or pi over 6 is what? Then we go on to 45 or pi over 4. This one's not so bad. Then we go to 60 degrees or pi over 3, which now looks like what? The opposite of 30. And then we finish up with 9 degrees or pi over 2, which is 0, 1. All right, so the question is what patterns do you see? Looking at the coordinates, we kind of brought up one where 30 and 60 are reverse of each other, but do you see any other patterns? 45 is the same on both. What about going, bless you, what about going, looking at the y values? Let's start with the y values first because it's easier to see in the y values. Starting from the bottom, going all the way up, what do you notice? Look at the numerators. Ignore the square root, but look at the numerators by themselves, just the numbers. Well, the first one is 1, because it's just 1. What's the numerator of the next one? 1, 2, 3, and we'll get to that one in just a moment. 0, 1, 2, 3. What should be the next in line? 4, and it is because it looks like this. See that square root of 4 over 2? Which is 2 over 2, which is 1, and that's why it's 1. But yeah, it's 0. And I'll go ahead and do this in red, so it's 0 over 2, 1 over 2, 2 over 2, 3 over 2, 4 over 2. Do you see those patterns? Look at it going down now, looking at the x values. What do you see there? Same exact pattern, right? The other way around. So if I was asked you to fill in the first quadrant of the unit circle, know the pattern. Okay, I'll start with my y values and start with 0, 1, 2, 3, and then I'll do 4. I'll put a square root over all of those. I can get by with that. I can do the square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and square root of 4 over 2. Do y'all see that? Now the deal is I got to go back and reduce. Square root of 0 is 0. 0 over 2 is 0. So that's why the answer is 0. Y'all follow me? Square root of 1 is 1. So it's 1/2. Square root of 2, just square root of 2. Square root of 3, leave the square root of 3. Square root of 4, you already seen what that's happened. So that's a pattern. That's an easy way to go through and figure out and find the first quadrant. Is by going through and doing that type of pattern and repeats on the x value, except from the x value it starts at the top and goes down. Alright? So that's the pattern we're going to use. Now the idea is, what if I was to ask you to find a specific, what's the sine of 30 degrees? Well, right now, guys, can you guys remember? Sine deals with what values? What values? Opposite of our hypotenuse, but we're not using that anymore. Say that louder. Y values. I had you guys write this a few times yesterday. So, cosine deals with x values. So if I'm asking you to find the sine of 30 degrees, go to 30 degrees on that first quadrant. What is the y value? 1/2. So the sine of 30 degrees is 1/2. What about the cosine of 60 degrees? It's 1/2 as well. Landon, what's the sine of 45 degrees? Perfect. Sebastian, what is the sine of 30 degrees?
It's square root of 3 over 2.
Sine.
Oh, the sine. 1 over 2.
Yep, 1/2. I asked the same question earlier. I just didn't mix it up. Sorry. Rylan, what's the cosine of 30 degrees? What's the x value at 30 degrees? There you go. Rhett, what's the cosine of 45 degrees?
Square root of 2 over 2.
Good. Aiden, what's the sine of 90 degrees? What? What's the sine of 90 degrees?
1.
1. Good. Darcy, what's the cosine of 0? 1. So what you guys are doing is you're finding the angle that I'm asking you. Then you go in and say, okay, is he asking sine or cosine? Sine is the y value, x is the cosine is the x value. You just find that certain coordinate and use it. So let's go ahead now. And that's all beneficial because every time I asked you a question, you guys looked at this one and referred to that every time. Well, guys, you're going to do this once, the unit circle, and then I'm just going to take it, and then you're going to take the rest of the exam, or rest of the quiz. So that means, well, how can I find it just without using this at all? And that's where the square root trick comes in, okay? So, square root trick, what you're going to do is you're actually going to have to memorize this. And so we go ahead and we fill it in just like this. At the very top, you write sine. Below that, you put cosine. Every single thing is a square root of some number over 2. So put 2 on the bottom. And then we go through and we start looking at it and saying, okay, starting with sine, which is the y values. Start with 0, 1, 2, 3, 4. Cosine is 4, 3, 2, 1, 0. And now we just have to figure out what degrees those deal with. And they actually start with 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90. And now I've seen this as well because it makes life a little bit easier because they're going to ask questions in radians. So go ahead and put the radians of it above as well. So 0, pi over 6, pi over 4, pi over 3, pi over 2. So now the way you do this is when I ask you sine or cosine, you go to that particular row. And so now if I say the cosine of 30 degrees, that means cosine of 30 degrees, which is the square root of 3 over 2. If I ask the sine of 90 degrees, there's a sine to go out to 90. Square root of 4, what's the square root of 4? 2 over 2, which reduces to 1. Then we go ahead and say the sine of 45 degrees. Sine's on top, square root of 2 over 2. You see how that works? I can also now go and ask you, what is the cosine of pi over 3? We'll go to pi over 3. Cosine is the bottom, so it's a square root of 1. What's the square root of 1 reduced to?
1.
1 over 2, so it's 1/2. Cosine of pi over 3 is 1/2. And so you can find that using the square root trick. Now, in that saying, you got to memorize this. Of course, it's a lot less memorizing than the whole unit circle. And the good idea about this thing is it finds your answers directly. But you're using this. If you don't have that accessible, and I don't want you to draw all of that, you can also do this. That's the logic. Oh wait, if you need to find, like we've had it in the years where we've gone through and said, okay guys, memorize the unit circle so you can use it to answer the questions. Because Trent just asked, can I just go to the first quadrant like we just did above and find out exactly the same questions I asked you guys? I said, yeah. Problem is you have to memorize the first quadrant. Well, then they come back and say, well, I have to memorize this, don't I? It's the same thing. I got to memorize something. True. And that's why I came up and did research and found the hand trick. The hand trick always seems to work for me because it's more tactile. It kind of fits exactly with what the unit circle is. So, The good thing is you're not really memorizing specific values. You're kind of memorizing patterns. At the top, 0, 1, 2, 3, 4. At the bottom, 4, 3, 2, 1, 0. At the top, the degrees, 0, 30, 45, 60, 90. At the very top, 0, pi over 6, pi over 4, pi over 3, pi over 2. Anyways. All right, so there you go. That's how you find the value. So if I'm asking you to find the sine of something, cosine of something, you can easily turn in and do this. So let's go ahead now and look at, unfortunately it goes away. Wish I could figure out a way to make that stay. So now let's go ahead and talk about, well, you find the value is one of them. Now you've got to find the sine is the other. And so they have this idea here. All students take classes. Well, guys, in the first quadrant, now talking about sine and cosine, we already said sine deals with y, cosine deals with x. In the first quadrant, which trig function is positive? In the first quadrant, both. So we use all, which is sine and cosine are both positive. And then we go into the second quadrant. What trig function is positive in the second quadrant? Cosine is the x-axis. Sine is the y-axis. So in the second quadrant, which axis is positive? In the second quadrant. Yep. Yep. It's going to be the y. So, in this quadrant, sine is going to be positive. And then we go through and we say, okay, in the third quadrant, none of them are. So we'll talk about this in a moment. We put t in there, and I'll show you why, because it represents tangent. And then we go ahead and finish up with the last one. In the fourth quadrant, what trig function, the only trig function that's positive is cosine. So then we go and let's talk about tangent real quick to get it out of the way. All right? Tangent, as we know, is, if we were talking about triangles, tangent is what over what?
Opposite over adjacent.
Opposite over adjacent. So tangent ends up being, well, according to what else uses opposite in trig functions, guys?
Sine.
What uses adjacent?
Cosine.
That ends up turning into that, sine over cosine. Tangent goes from opposite over adjacent, which we don't use that anymore because now we're talking about unit circle. Now we're moving on to sine over cosine. Well, let's go even further. Sine deals with what values, guys? Cosine deals with x. So let's go back through these and see which one now, tangent, what's the value of tangent in each one of these quadrants? Well, if sine and cosine are both positive, what's the value of tangent in here? Positive, well, because a positive divided by positive is?
Positive.
Positive, right, Aiden? Correct. Thank you. So then we move on to second quadrant. Y values, which we said is on top. Y values is going to be what? Positive or negative? Positive divided by x values. In the second quadrant, x values are negative. What's a positive divided by a negative? Negative. So that means that in the second quadrant, tangent is going to be negative. This is the reason why the word all is here, because that includes sine, cosine, and tangent are all positive. When you go into the second quadrant, sine is the only function, because now cosine and tangent are both negative. And then, of course, if we go into here, well, in the third quadrant, guys, y values are positive or negative? Negative. X values are positive or negative? Negative. What's a negative divided by negative? Positive. So that's the reason why tangent is the only positive function here. And then finish off with cosine. And cosine ends up being the only one that's positive there for the same reason in second quadrant. All right? Good. Now let's move on to, well, that helps us with the value. So now, guys, using the square root trick, you can find the value of the function. You can find the value of the function. And now using this trick here, you can find the sine of it. That completes it. However, you are still lost if they give you a radian. If it's in radians, you still to now are going to have to convert to degrees. So now let's figure out one last trick. You can finish that after this last trick, okay? The one last trick is, guys, is this. If I have radians, how can I tell? Because here's the deal. I don't really care what the degrees are. 3 pi over 4, I don't care really what the degrees is. Just tell me what quadrant I'm in. And then I can use this here. So just tell me what quadrant I'm in, and this is what we use, guys. So it's pi over d. So in the first quadrant, pi over 3, pi over 4, pi over 6. Those are all in the first quadrant. And of course, pi over 4, pi over 3, pi over 6, you go up to the square root, you can find out which one that is. If you're in the second quadrant, it's d minus 1 pi over d. So if I'm dealing with pi over 4 is the reference angle, pi over 4 is the reference angle, in the second quadrant, it's 3 pi over 4. Third quadrant, it's plus 1. So in the third quadrant, it's 5 pi over 4. And then find the last one. It's a little bit lengthier, but it's double the denominator and subtract 1. So you're looking at 7 pi over 4. No, that's horrible. But the red is your example. So if pi over 4 in the second quadrant ends up being 3 pi over 4, in the third quadrant is 5 pi over 4, and finally the last quadrant is 7 pi over 4 because it's double. Sure. Ains won this one. I just mean that. All right. It's a lot of stuff, a lot of tools to put it all together to find just one simple problem. And we'll see what that looks like now. Five pi over 6. Here's your steps to find these functions without using a unit circle. First step. Find reference. Find your reference angle. When we first started this unit, we talked about reference angles very briefly. It was something you guys started noticing. And it was the activity I had you do in class, the classwork. You guys were taking radians, converting them to degrees, finding the reference angle, and then converting back to radians. You did that so often, then I started asking you, do you see anything that's in common with all of those radians reference angles? And you guys found out. Oh, basically, whatever it is, pi over 6, its reference angle is pi over 6. We ignore the number that's here. So basically, guys, I'm asking you this. Find the sine of pi over 6. So find the reference angle. Find the value of that reference angle. So now, pi over 6. Go to your square root. Flip your notes over. Flip your notes over. Go to sine. Go across to pi over 6. What value do you get to? What number?
Pi over 6, which is 30, but it's actually a massive net.
It's 1. Square root of 1 over 2, which reduces to what? 1/2. So basically this is 1/2 and then finally finish it up. Find the sign. Well, according to our little chart we did with b plus 1, b minus 1, and 2d minus 1, what quadrant is 5 pi over 6 in? How do you know that?
Well, I just want to do a circle.
You just
But-
don't need a circle. Okay.
Yeah, but, like, because you do 6 minus 1 pi.
Look at the bottom of your notes. Flip them over. Look at the bottom. If you look at what 6 is compared to 5, it's just minus 1. So where is minus 1? Second quadrant. I've seen people write a shorter version of it. I kind of put a lot of detail into it. But I've seen people do this. There. From bottom to top, plus 1, minus 1, times 2, minus 1. I've seen people do that too. Just kind of shorter version of the same thing, okay? So good, we're in the, you said second quadrant. So in the second quadrant, you take the all students take classes deal. Is this answer positive or negative? What letter is in the second quadrant? S, which stands for sine, which tells you sine is the only trig function that is positive in the second quadrant. So this answer is done. Let's go on to another one. Let's look at the sine of 4 pi over 3. Go through our steps. What's the reference angle of 4 pi over 3? Don't say degrees. Keep it in radians, please. Pi over 3. What is the sine of pi over 3? Flip it over. Look at the square root. Square root of 3 over 2. Did y'all find it? Pi over 3, which is 60 degrees. You go there, go right below. The very first number you see is 3, so it's the square root of 3 over 2. Now, what quadrant is 4 pi over 3? Third quadrant. Because what do you do from 3 to get to 4? Plus 1. Look at our little diagram over there. Plus 1. Oh, did I say... Guys, you got to correct me on this. I'm sorry. I got those mixed up. Sorry. I got those mixed up. I'm like, wait, it should be in the third quadrant, and it is. So we're in, this angle is in the third quadrant, which means that y values, I'm saying y values because it's sine, y values, are they positive or negative? And done. Reference angle, value, sine. 3 steps, that's it. So let's go on to the next one. Cosine, let's do number 5. Cosine of 5 pi over 3. What's the reference angle? What is the cosine of pi over 3? What quadrant is 5 pi over 3? Fourth quadrant, which tells you cosine is positive or negative. Positive. Reference angle first. Value second, which uses the square root. Sine, which uses the plus 1, minus 1. And just find out. Guys, that all students take classes is a nice trick, but let me tell you this. I don't think you really memorize that. If you know the fact that x's are cosine and sine are y's, if you know that, then you can just look at a simple coordinate plane and say, hey, in the first quadrant, x and y are positive. Second quadrant, x is negative. Third quadrant, both of them are negative. Fourth quadrant, y is the only one's negative. And just stick with that. You guys have been looking at coordinate planes ever since you've been starting algebra. Some of you guys, that's in 9th grade. And you know where positive and negative values are on the coordinate plane. If you don't, I don't know how you made it all the way to pre-calc. So you know where those negative values are. So I would probably not just take the time to memorize all students take classes. I'd just say, hey, first quadrant, both of them positive, second, so forth, and go around like I said earlier. I'd probably just do that. But if you're not getting it, go ahead and try the all student takes classes. That's fine. All right, and I skipped those because I wanted to go straight to, I wanted to do the radians first, and now we'll go back and look. So now cosine of 240 degrees. First step, reference angle. What's a reference angle of 240 degrees? Good job, guys. All right. So with that, we're here, 240 degrees, which you guys were right. It is 60 degrees. So we're actually asked to find what's the cosine of 60 degrees, guys. One half. Good thing about degrees, guys, there's no plus one, minus one you need to know. You just say, hey, 240 degrees, that's in the third quadrant. Oh, by now you kind of know that too. So for the third quadrant, x values, are they positive or negative? Negative. Reference angle, value, sign. All right, let's finish with the fun one, tangent. So tangent, guys, the way you do it, and the reason why the square root looks like what it does, is because we've already established it earlier. Tangent is sine over cosine. We'll go back and look at your square root, guys. Square root trick. What values did we put on top? Sine. And it just so happens that, hey, it's the order it needs to be. So tell me, what is the tangent of, well, I don't want to do this right now. Let's do this one here. What's the reference angle of 315 degrees? 45. Go to the square root. With tangents, guys, you're going to ignore divide by 2. And you'll see why in just a moment. But let's just go ahead and ignore it for now. Okay? What is under tangent? It's the sine over cosine. What is under the square root for 45 degrees? Square root of 2 is the sine. Square root of 2 is the cosine. It's the same. So it's actually 1. Yes, ma'am. Put that here. Sorry. This thing is here. So it's square root of 2 over 2 equals 1. I'll try right up here in this space. There you go. So then we ask, okay, reference angle found, 45 degrees. Value found because it's sine over cosine, which is root 2 over root 2. I said ignore the divide by 2. That's gone. And I'll tell you why just briefly, guys. If we were to put the sine like this, if we were to put sine over cosine, what is the sine of 45 degrees? What's the cosine of 45 degrees? It's the same, right? Well, we always ignore the divide by 2, guys, because this is always what happens. What when you do when you divide by fractions, what do you do, guys? What's the process? Keep, change, flip. What is always going to happen? Those 2's will always cancel. Because as we said, sine, cosine is always divided by 2. Which means you always have something divided by 2, divided by something divided by 2. Which they will always cancel out. So basically, guys, when you're looking at the square root for tangent, just put whatever is on top, the square root of whatever is on top, divided by whatever is square root on bottom. So if I was asked to find the tangent of 30 degrees, I put the square root of 1 over the square root of 3. If I was asked to find the square root of 60 degrees, I do the square root of 3 over the square root of 1. All I'm doing is just looking at what's under the square root, and that's it. For tangents. Let's finish it off. Is this value going to be positive or negative? Well, what quadrant are we in again in 315? Fourth quadrant. So it's negative. Why is it negative? Because I should have wrote this a little bit better. I should have said this is negative root 2 over 2. Isn't the sign values in the fourth quadrant negative? Yes. All right. Finished up with the one that, whatever. Okay, so let's use our rules. Let's use our rules for reference angles with radians. What's going to be the reference angle of 3 pi over 2? Pi over 2. Go to your square root trick. What over what for pi over 2? Look at pi over 2 in your square roots. Look under the square root and what two numbers are there? 4 and 0. You notice I'm still writing the square root, guys, because it's all under square root. So make sure you're writing square root. What is the square root of 4? 2. What's the square root of 0? 0. Which is, what do I multiply times 0 to get 2, guys? Can't. Or whatever. All right. Skip 7 and 8, and I want you guys to do 9 through 12. At what degree would sine of, well, whatever degree it is, equal 1/2? Well, go to your square root, guys. Where do you see sine being, and it says degrees, so give me, what degree is sine 1/2? 30. So basically we have the sine of 30. Whoop, that's not going to work. Equals 1/2. 30 degrees, but guys, we've learned something else. Sine is what values? Y. Is y positive somewhere other quadrant somewhere else? What quadrant is sine also positive? Second quadrant. So what is 30 degrees in the second quadrant? Yes, it is. So one thing about math is you always got to learn it forwards and backwards. So yes, we'll ask your question the same way, forwards and backwards. At what radians would tangent be undefined? Well, let's figure out. First off, it'd be best if we know what is undefined. Well, we already came up with an undefined answer, didn't we? What was the scenario that gave us where it was undefined? What was the problem? Why was it undefined? There you go. 0's on bottom. Look at your square root, guys. What value, how about this? What values are on the denominator for tangent? It's what divided by what? And don't say opposite over adjacent. We're going to use sine and cosine. So I'm actually asking you, the question is, where is cosine 0? Cosine deals with what values, guys? X values. Where is x equal to 0 on the unit circle? Wait, it's saying radians, isn't it? Pi over 2 or 3 pi over 2. So it's all on the y-axis, isn't it? It's at the top part of the y-axis or at the bottom y-axis. Because that's where x equals 0. All right?